Assalamu alaikum. Well, children, yesterday we completed the first exercise of trigonometry chapter based on definitions. So by now, definitions of the trigonometric ratios, 6 trigonometric ratios, must be fully understood by you. We'll quickly again go through those definitions. 3 of them are obtained from that statement: sine, cos and tan. Sine is perpendicular by hypotenuse. Cos is base by hypotenuse. Tan is perpendicular by base. And the remaining 3, cot, sec and cosec, those are reciprocals of these first 3. Tan and cot are reciprocals. Sec and cos are reciprocals. Sine and cosec are reciprocals. So accordingly we get cot as base by perpendicular, sec as hypotenuse by base, cosec as hypotenuse by perpendicular. We have read that earlier. Then you were told these trigonometric ratios are meaningless unless the acute angle is written with those. So therefore that is why we say sine A or sine theta. We simply don't write sin. That is nothing. Then it is an English word, sin. We write cos theta. If we do not write theta, it is cos, nothing. You cannot find in the English dictionary also that cos anywhere. That is nothing then. Now it becomes meaningful with that alphabet, with that angle theta. It is cosine of angle theta, full form. It is not the product of cos and theta. We have discussed it. Now in this part of the chapter, the first exercise, acute angle was in general used. Somewhere A, somewhere B, somewhere P, somewhere R, somewhere theta. Now we have to use the values of those acute angles. You know, an angle is called an acute angle if its measurement is from 0 to 90 degrees. Any angle between 0 degree and 90 degrees is called as an acute angle. And therefore, any of those measures can be given to the acute angle here. If we suppose that angle is 10 degrees, then sine 10 will be written instead of sine A or sine theta. Now we have 10 degree as acute angle. If you choose 50 degree, then you can write cos 50 degrees. Here 50 degree is the acute angle. We don't have now A written there. A specific angle is used here. 50 degree, 10 degree. So any angle, any measurement between 0 and 90 degree can appear here after the trigonometric ratio. Sine, cos, tan, cot, sec, cosec, any trigonometric ratio and any acute angle can be used there. And then those will have definite values. Each acute angle will give a definite value to the trigonometric ratio. Sine 1 will have its value. Sine 2 degrees will have its own value, different from sine 1. Sine 3, likewise up to sine 89. You will get different values. Similarly, coses, tan, cot, sec, different values will be there. Now at this level, you are not supposed to use all those acute angles. You have to use only 3 acute angles. That is why the title of the topic here is trigonometric ratios of some specific angles. Not all acute angles. Only some specific acute angles. And you have to use here only 30 degrees, 45 degrees and 60 degrees. Only these 3 specific acute angles you need. The values of these you will have to frequently use as we proceed in the chapter. You need to know those values. What is the value of sine 30 degrees? What is the value of cos 30 degrees, tan 30 degrees, cot 30 degrees, sec 30 degrees, cosec 30 degrees. Likewise, 45, sine 45, cos 45, tan 45, and so on, 60. These specific acute angles, the values of trigonometric ratios for these specific angles will therefore derive. And after derivation, you will put them in the form of a table and try to memorize them. You have to learn them so that we can use those later. Besides these, we shall also be giving you, those will not be derived, trigonometric ratios of 0 degree and 90 degree. Now look, these are not acute angles. 0 degree and 90 degree. You have to derive only trigonometric ratios of acute angles, specifically 30 degree, 45, 60. Now besides those, we'll give you the values of these also. Together with these specific acute angles, we'll then arrange them in the form of a table and try to memorize them, and later on, wherever the need will arise, we'll use them. Derivation of trigonometric ratios of 30 degree and 60 degrees will be same. This 45 degree derivation of trigonometric ratios of 45 degree will be different. We'll first derive these two. And out of these also we'll first derive trigonometric ratios of 60 degree. So you write a question, derive the trigonometric ratios of 60 degree. This will be our question under discussion now, and later on same procedure will be used for 30 degree also. Let us see how we derive these 60 degree and then follow accordingly for 30. For the derivation of trigonometric ratios of 60 degree, we need an equilateral triangle. So you draw an equilateral triangle on your copy. Consider this triangle to be an equilateral triangle. I have named it ABC. Being an equilateral triangle, it's all the three sides will be equal. Let us suppose the length of each side is 2a, small a, 2a is the length of each side. Length of AB side is 2a, length of BC side is 2a, length of AC side also is 2a. Now why we choose equilateral triangle here? Because we know each angle of an equilateral triangle is 60 degrees. And that is the angle which we have to use. We have to find trigonometric ratios of 60. We'll have this angle B as 60 degree here. This angle also 60 degree. This angle also has 60 degree. All the angles here are 60 degrees. Trigonometric ratios of any of these angles we'll choose and we'll later find. Then you were told last time that trigonometric ratios are defined only in terms of right triangles. And when we look at the figure that we have drawn an equilateral triangle. It is not a right triangle. Therefore, we would like to have a right triangle in the figure. To get that, a perpendicular will be drawn from A on BC. Let us name AP. What we call in geometry as construction. This is like that here also in trigonometry. A perpendicular is drawn from the vertex A to the side BC. AP I have named it. This gives us two right triangles. Right triangle ABP, right triangle ACP. These two right triangles. And later we'll use one of these. We'll apply definitions in only one of these. We need not apply definition in both of these. Only one later will be used. Now before we use those definitions and get the trigonometric ratios of 60 degree, you were told earlier, in the previous exercise you have seen, before applying the definitions of different trigonometric ratios we required there, we were supposed to know the lengths of all the three sides. Unless we know the lengths of all the three sides, we cannot use those definitions and get the results. So therefore, our first effort will be to find the lengths of all the three sides. Suppose we choose this triangle ABP. Presently, you know the measurement of only AB side of this. Its second side is BP, we do not know the length. This 2A is the length of BC, not BP. We need BP, the side of this right triangle. Third side of this right triangle is AP. We do not know the measurement of that also. Only one side of the right triangle therefore is known. So we will therefore try to find the measures of two of the sides of this, remaining two sides. BP as well as AP we would like to find. Now how will we get that? We'll first prove these two triangles formed here by drawing perpendicular or congruent. Congruency of triangles you have read in class 9. Different rules, SSS congruency rule, SAS congruency rule, ASA congruency rule, RHS congruency rule, and then ASA corollary also, AAS corollary also we have done. Any of those rules will be used to prove these congruent. We'll begin with the congruency, therefore, let us first prove them congruent. In triangle ABP and triangle ACP, we have congruency we have to prove. And look, we have in these two triangles AP as the common side. We have side AB equal to AC, each is 2A, sides of equilateral triangle. We also have this angle 90 degree, this angle 90 degree, AP is perpendicular on BC. That will be one way of proving them congruent. You have used RHS congruency rule. But we also have this angle, angle B 60, angle C 60. You can use this also in the congruency. And the congruency rule you can also use therefore is AAS congruency rule. 60, 60, 90, 90, common side AP. AAS also can be used. So one of the congruency rules you will use, let us use RHS congruency rule. So we have angle APB equal to angle APC, each 90 degrees. AB equal to AC, sides of equilateral triangle. Right there, equilateral triangle, sides of equilateral triangle. AP equal to AP, common side. So we have right angle, hypotenuse side. Therefore the two triangles are congruent by RHS congruency rule. Triangle ABP is congruent to triangle ACP. Rule used is RHS congruency rule. And then whenever we prove congruency, we use CPCT, and according to CPCT here we shall say BP is equal to CP. CPCT. Now being equal, BP being equal to CP, together these make the line segment BC. Therefore, each of these will be half of BC. So we write is equal to half of BC. Length of BC we know is 2A, so it will be half of 2A. We replace BC by 2A. 2 will then cancel with 2. Therefore, BP as well as CP will be equal to A. That BP will be the second side of this right triangle. AB already we have 2A. We got BP now also as A. Now remains the third side AP. And you have seen in the previous exercise, wherever we knew two sides of the triangle, third we found by applying Pythagoras theorem. We'll use here also. To find this AP, we'll use Pythagoras theorem. Let us apply. We know in this right triangle, this being the right angle, which side will be hypotenuse? Yes, it is AB. So it is AB square, hypotenuse square, is equal to BP square plus AP square by Pythagoras theorem. Hypotenuse square is equal to sum of the squares of the other two sides. Out of the three sides involved here, measures of 2 are with us. We know. Let us use those and try to find out the third. AB is 2A, so it will be square of 2A is equal to BP we have just now found A, so it will be square of A plus AP we would like to find. AP square will remain as it is. Simplifying, it will be 4A square is equal to A square plus AP square. To simplify further, there are two like terms. To combine them, you have to transpose. A square will be transposed. 4A square minus A square is equal to AP square. 3A square is equal to AP square. And that will give us AP then equal to get AP, square will be transposed, it will become square root, so it will be square root of 3A square, which in turn will give us square root 3A. Square root will cancel with the square of A. 3 does not have square, so therefore that 3 will continue to be on the radical side. It is square root 3A. This is the measurement of the third side, AP. Now knowing all the sides of this triangle, we'll use definitions to find trigonometric ratios of 60-degree angle. With respect to this 60-degree angle, if we draw this right triangle here roughly, this is P, right angle here, this is A, this is B, and this angle we have 60. This measurement we have 2A, this measurement we have shown is A, and AP we have shown under root 3A. And then what we used to do in the previous exercise, with respect to the angle chosen, we used to decide which is perpendicular, which is base. Hypotenuse, of course, we know is the side opposite to 90-degree angle. So therefore this is hypotenuse, 90 degrees, side opposite to 90-degree angle, hypotenuse. Base with respect to 60-degree angle will be its adjacent side, that is this BP, this will be base. And then third side is perpendicular. All that we have learned earlier. Here we decided the side is with respect to 60-degree angle, because we have to find trigonometric ratios of 60 degree. 60. Base is BP. AP is perpendicular. AB is hypotenuse. We use definitions to get results. Now, sine 60 degrees. Look, instead of acute angle A, B, C, P, Q, theta, we have here 60 because we need to find trigonometric ratios of 60 degree now. So sine 60 is equal to, definition is same, perpendicular by hypotenuse. We have already identified perpendicular. It is AP. Divided by hypotenuse is AB. It is AP by AB. Now use their values. AP is square root 3A. AB is 2A. A in both numerator and denominator will be cancelled. The result therefore is under root 3 by 2. This is the value of sine 60. And you will have to remember this. Sine 60 is under root 3 by 2. You will have to use it frequently. Not only in this class, higher classes also. Remember, sine 60 is under root 3 by 2. Then find cos 60. If you recollect, you have used this cos 60 in the previous class. In the chapter Work, Energy and Power, you had one expression for work in terms of cos theta. W is equal to Fs cos theta. In that we have used theta as 60. Cos 60 we had there. If you recollect the value, it is 1 by 2. That 1 by 2 value of cos 60 will get today here by using definition procedure we have already learned. Cos definition is base by hypotenuse. Now we have identified base, it is BP, divided by hypotenuse is AB. Use values, BP is A, AB is 2A, again A and A will cancel, therefore what is left? 1 by 2. It is this 1 by 2 that we get here on calculation that you have used in class 9 in that chapter. Cos 60 followed by tan 60. Definition of tan is perpendicular by base. Now use their names from the diagram. You have already identified base and perpendicular. Perpendicular is AP divided by base is BP. Then put their values. Under root 3A for AP, A for BP. A and A will then cancel. What is left is under root 3. This is the value of tan 60. These are the three we get from the statement. Some people have curly black hair to present beauty. Remaining three again are the reciprocals. Cot is the reciprocal of tan. Tan 60 is under root 3. Then cot 60 will be the reciprocal of this. You can directly write, you know tan 60 is root 3, cot will be reciprocal of that. Or if you want to complete the whole procedure, you can do tan 60 is perpendicular by base. Cot 60 will be then base by perpendicular. BP will be shifted to the numerator, AP will go to the denominator. Accordingly, the values will be shifted. You will get 1 by root 3. Cot 60. Base by perpendicular. Reciprocal of tan. It is BP by AP. So values A by under root 3A. Again A cancels. 1 by under root 3. This is the value of cot 60. Then sec 60 and cosec 60. Sec 60. Well, it is reciprocal of cos 60. Cos 60 we have just now found is 1 by 2. It will be therefore 2 by 1 reciprocal, which means 2. So you may find this way or the way just now we have got cot complete procedure. That way also you can do. This way you can also use. Then cosec 60. Cosec is the reciprocal of sine. So it is reciprocal of sine 60. We have just now got sine 60 value. You can find it is under root 3 by 2. Reciprocal will be 2 by under root 3. Therefore, value of cosec 60 is 2 by under root 3. That completes our first question, derivation of trigonometric ratios of 60-degree angle. Now, second question will follow accordingly. And this time, we will find trigonometric ratios of 30-degree angle. You write a question, derive trigonometric ratios of 30-degree angle. Derive trigonometric ratios of 30-degree angle, and for this also, like previous case, we need an equilateral triangle. You draw again this equilateral triangle. And this time also, each side we shall take as 2A as we did in the previous case, and then perpendicular also is drawn. All this is required again here. Each angle of the equilateral triangle is 60 degree. We have 60 degree angles in the figure. But we are not supposed to find trigonometric ratios of 60 degree. we have to find this time now trigonometric ratios of 30 degree. We need to show, therefore that will be the additional part, which angle is 30 degree in this diagram. So what you will do is, your congruency part will be same. You have to prove the two triangles again congruent here, as we did in the previous case. RHS congruency rule we used. And then we wrote there according to CP/CT, BP is equal to CP. This was first CP/CT result we used there. From there, by using the relation half of BC, we got half of 2A, 2 cancels, A as the value of BP and CP. Up to this part, there is no change. You have to repeat that part of the previous question, up to this. Now will be the new thing. We need angle of 30 degree, that will introduce here. First CP/CT result we have used BP equal to CP. In this case, you have to now use the second CP/CT result also. And this will give us these two angles equal according to CP/CT. So you write also angle BAP is equal to angle CAP, again by CP/CT. Because the two triangles we have already proved congruent. That congruency you have in the previous solution. You have to repeat that here. Two CP/CT results this time we have used. Earlier we used only one because that time only one was required. Now we need the second one also. These two angles we have taken now equal. Each of these angles will be then half of the whole angle which the two angles together make. Angle BAP, angle CAP together make larger angle BAC. So it will be half of angle BAC here. Earlier we said BP and CP together make BC side. So therefore each side will have length equal to half of the whole side, BC. Used here. Now angles are there. Each will be then half of BAC and the measurement of BAC is 60. Use that, half of 60. 2 30s are 60. Here is how we get that angle 30 degree which we have to use. We need trigonometric ratios of 30 degree. We have shown that this angle is 30. This angle also is 30. And as in the previous case, we'll be then later using only one of the two right angles. We'll again take the left hand side one. But that doesn't mean that you cannot use the right side one. You can use that also. One out of the two you have to use. Now having done this, then again you will have the procedure of previous question to be repeated. We applied Pythagoras theorem there. In this right triangle we used Pythagoras theorem to get the measurement of third side AP. So that portion will be again repeated. Let us write that again. We know AB square is equal to BP square plus AP square. This is Pythagoras theorem. Three sides are involved in this and the measures of two of them we know. The procedure will be same. What we will do is put the value of AB, it is 2A, square of this. Value of BP we have just now found, A, square of this. We want to find AP, AP square. Now when you repeat that procedure from the previous question, you will find AP again is equal to under root 3A by 2. Procedure, those steps I have left, you will consult the previous solution and write the steps. AP is under root 3A by 2. It is repetition of this portion done in the previous case. Thus, knowing all the three sides, next we applied definitions in the previous case also. Here also we'll use the definitions. We'll again choose only one right triangle, the right triangle APB. Roughly again I shall draw that here. This is the one. This vertex is P. Here is A. This is B. We have this side as hypotenuse opposite to 90 degree. Measurement length of this is already we know is 2A. BP we have found is equal to A. AP we have found is under root 3A by 2. Now in the previous case, we had to find trigonometric ratios of 60 degree and we had this angle as 60 degree. So with respect to this 60 degree angle, we decided base and perpendicular there. But now in this question, you have to find trigonometric ratios of 30 degree, and we have just now shown this angle is 30. Angle BAP is 30. Location of acute angle therefore has changed. Instead of 60 degree, now you have 30 degree angle. You have to use 30 degree now to decide which side will be base and perpendicular. Since acute angle has changed, perpendicular and base will also change. Now this will be the base. This will be the perpendicular. This time BP is perpendicular, AP is base. Hypotenuse will remain same, opposite to 90 degree angle. And with this change in perpendicular and base, the values of trigonometric ratios will also change. 30 degree, 60 degree, now there will be change. 60 degree we have already done, now use 30. So let us find sine 30 first. Definition again is perpendicular by hypotenuse. We have already identified perpendicular. It is BP. Hypotenuse is AB. Use their values. BP is A. AB is 2A. Again A and A will cancel. Result is 1 by 2. Sine 30 therefore is 1 by 2. Previously we got cos 60 equal to 1 by 2. 1 by 2 is again there. But it has now changed. Sine 30 is 1 by 2. Previously it was cos 60 which was equal to 1 by 2. Because of this change. Now cos 30 by definition is base by hypotenuse. And we have already identified base, perpendicular, hypotenuse in the figure. Our base with respect to 30 degree angle is AP divided by our hypotenuse is AB. Let us use their values. AP, yes, it is under root 3A only, not under root 3A by 2. Under root 3A divided by AB is 2A. Here A will cancel with A. Thus the value is under root 3 by 2. This is the value of cos 30. In the previous derivation also we got root 3 by 2, but that was for sine 60 degrees. Now it is for cos 30 degrees. When the angle has changed, value also has changed. Trigonometric ratio has changed. Cos 30 is under root 3 by 2. Then comes the turn of tan 30. By definition, tan is perpendicular by base. Naming them with respect to 30 degree angle, perpendicular is BP divided by base is AP. Using their values, BP is A divided by AP is under root 3A. Let us cancel A and A again. What is left? 1 by under root 3. This is the value of tan 30. So we got sine 30, cos 30, tan 30. Now the remaining 3 you can get either by using definitions or by writing reciprocals. We know cot is reciprocal of tan. So therefore cot 30 will be reciprocal of tan 30. Just now we got tan 31 by root 3. Reciprocal will become root 3 by 1 minus root 3. This is cot 30. Sec 30. Sec is the reciprocal of cos. reciprocal of cos 30, and we have already got cos 30 root 3 by 2. Therefore, sec 30 will be 2 by under root 3, reciprocal of this. And the last one, cosec 30, reciprocal of sine 30. Sine 30 we have seen is 1 by 2. Reciprocal will become 2 by 1, which means 2. That completes the trigonometric ratios of this 30-degree angle, and we will conclude the day today.